Hello everyone, today we are going to show you the assembly of this bench vise part, and this is chapter 12 tutorial 1, and in the previous videos we showed you how to make this individual part, and you should have all of them with you. And today we are going to use SolidWorks to assemble all these parts together and get this bench vise. Yeah, let's get started. So we go to SolidWorks and create a new one. So the new one, for this time, we're going to do assembly instead of the part because we're creating the assembly. So we do assembly and say OK. And the screen will pop up automatically to ask us to begin the assembly. And let's go to the folders that we had all parts. So make sure you place all the parts that we made in the same folder. And then it's too small, let's go to a large icon so we know what part we're going to grab. So let's grab the first part. So let's grab the vise body as our first part. So the first part and say open. And now SolidWorks is going to ask us to drop the first part. So whenever you dropped at the first, that part is going to be fixed, which is fully defined. So the position of the part is going to be fixed and you cannot move it anymore. So this is our first part. So I just click and put it here. And this part is going to be fixed. So as you can see, it has an F in front, means this is the first part and we make it to be fixed. Okay. And now let's grab another part to drop it in. So before we do that, let's take a look at the step, see what we are and how to assemble. So this is the part we just put down. As the next, we're going to select this part and put it in there and assemble this piece on the body. So let's go back to SolidWorks and bring in that part. So we go to assembly and select insert components. So insert, you could also do the drop down here, insert components, and it will pop up automatically the same folder. And now we are going to bring in the vise jaw and say OK and drop it anywhere that you want. And we are going to put relations or put a mates in between, so the part is going to be fixed. And as you can see, it has a minus sign in front because it's underdefined. So we are going to add some mates to make this part to be fully defined. So first of all, let's make the two surfaces are mating together. So we are going to select the bottom surface here and mate with this surface. And then we are going to select this side surface here and mate with this surface. And then we are going to give a distance so the part can only move from here until this edge. So we are going to go ahead and give this 3 mates. So as the first, we are going to give a first mate. So there is a mate under assembly. So click the mate. And now select the surface. Like we said, we are going to do the bottom surface here with this surface. So let's go ahead and select this two surface. Before you do that, make sure this part is dark so you can select the surface. So I am going to select the bottom surface as well as this surface. And now they are mating up and say OK for this. And then I am going to create another mate. So the mate here is highlighted. So I am going to select. So by doing that, the part can still move in this way because I only had one mate. So next, I am going to mate this surface with this surface. So I'm going to click this surface as well as this surface and say OK to this mate as well, or this one. And by doing this, the part can only move in this way and can't move front and back, can only be left and right. And the problem is it can still move out. Okay, so we need to add another mate to move the part that can only move within these two distances. So let's go ahead and select another mate. So at this time, I am going to select this surface with this surface and make the distance that can only be made up to here. Okay, up to here. So let's select the surface, this one, and the other one here. Okay, and now let's go to the advanced one. So there is the advanced mates. And let's open this up and they go to a distance. So there's a distance here. You click that distance and there will have you to input the smallest distance and the biggest distance. So the smallest distance between these two surfaces is going to be 0. And let's tap 0 there. And the largest one is going to be until this position right here. So let's figure out the dimensions. So if we go back and look at the dimension, the maximum one is going to be 144 minus this thickness, which is 16 plus 10, and minus this distance, which is 22, and minus the thickness of the vice jaw. So let's take a look at the jaw. So the thickness of that is 32. So let's put all those dimensions there, which is 144 minus 26 minus 22 and minus another 32. So let's go ahead and put this number there as our maximum. So it's 144 minus 26 minus 24 and minus 32 and say OK. And say OK for this mate. So the minimum distance is 0, the maximum is 64, and say OK. So now we can take a look at this part. So the part can only move within this space. Okay, so if you noticed, so actually here I made a mistake when I do the sketch, right? They are supposed to be up to here, the height. Okay, so let's go back of the previous slide. So they're supposed to be the same height. Okay, so actually when I made the dimension at the beginning, I made a mistake. So let's go ahead and fix this mistake. Before we do that, let's save the work first and say OK to the mate. And save the work first and rebuild and save. And when you save, make sure you save it in the same folder as all the parts. Otherwise, I cannot open that. Okay? And also, when you turn your homework in, make sure you turn in all the parts and assemblies together. If you only turn in assembly, I cannot open that. So make sure you put them in the same folder. And we could call this part as bench vice assembly. Assembly, and say OK. Once again, make sure they are in the same folder. Now let's go ahead and change this part. So we go to SolidWorks and open the previous one. So click open. Then this was the part of the vice body, and say open. And this is the part. Actually, I messed up the dimension there. So it's for it's under sketch 1. Okay, sketch 1. So I click sketch 1, go to sketch and select a sketch. And now let me go to a front plane so we can see it better. So actually the 36 here, I messed up. So if we go back, and the 36 should be from the top until this line. What I did was from the top to the bottom. So that was my mistake. So I am going to go ahead and change this dimension from the top until this surface instead of all the way below. So let me go back here and delete this dimension. So this dimension is deleted, and go to Smart Dimension and redo this part and make it as 36 and say OK for the dimension. Then save the work, and we'll ask us to rebuild. Just say OK with that. And let's look at the new part. It looks like this. It has a line there. So let's save it one more time and click the sketch maybe and save it one more time. Then that line disappeared. And this is our new part. Let's give a good view and save it. And let's go back to the assembly, and it will ask us to update and rebuild and say OK with that. And the part get rebuilt. Now they have the same height. Okay, they have the same height. Now let's continue. So before we do that, let me close the vice body part because we don't need it anymore. And let's look what's the next step. So we completed this. In next part, we're going to bring this part and insert it into this hole. So let's go back to SolidWorks and insert components and click that and find the bar. So actually the jaw screw is the thing that we are looking for. Don't select the screw bar, it's for something else. So select the jaw screw here and say open and drop it off in a random place that you like. And now we are going to put the mates. And let's click the mate, and we're going to make this one and the hole to be concentric. So select this as well as the hole is automatically recognized as concentric and say OK with that. With that, then the part will only move in the center of the hole. And as the next, we're going to make this the bottom, the inside surface there that is coincident with the surface. So let's select this surface as well as the inside surface, and this is the surface. So make them to be coincident, which is recognized automatically, and say OK with that, and say OK with the mating part. And notice that by doing that, so the vice jaw, which is this part, is fully defined, does not have a minus sign in front. And the vice body, like we said, is the fixed part. It's the part we brought in at the first, so it has a fixed in front. But the screw, the jaw screw, still have a minus sign in there. The reason of that is we give two mates there. The bar can still move, as you can see this, right? It can rotate. And this is what actually this part is supposed to be in reality. So we are not going to force this part to be fully defined, because in reality we are supposed to have this motion. So we will just leave a minus sign in there. And if I grab the bar, so I can remove the vice jaw automatically, because I made them made together. And in reality, it should not be the case. In reality, we should have a pin here and put it there. And that's the next step we're going to do. And also with the part that you already made, then you could also check the mates that you did. So for example, for the vice jaw, then you expand that, and all your mates is going to be here, all the mates that you did. So anyway, and next part, we're going to put the bottom piece, which is this piece, on it. So it has directions. So we want to make this direction outer because it has countersink holes. So let's see how to do this. So let's go back to SolidWorks and insert components and select this part, clamping plate, and open and drop it down in a place that you like. And now we are going to put this part in here. Okay, so put this part in here. Like I said, it has a direction, so supposed to be this surface. Put it right here, and put the other surface out. So let's go ahead and put it there. So I am going to add a mate one more time. So select this surface, the edge. No, this is not what we want. To delete that, and select the surface, and select this surface, and coincident. Yeah, actually it's recognized automatically, but you can, as you notice, the direction is wrong, right? The direction is wrong. So let's flip the direction by click this button. Okay, flip the direction, click this button. So the part is flipped around. Okay, so this is the right direction. Now we say okay. And the next thing, we are going to add concentric relations. So this two holes supposed to be concentric, and this two supposed to be concentric as well. So let's select this hole as well as this hole, and say they're concentric. Actually, it's automatically picked, so say okay with that. And let's add another two, which is this hole as well as the other at the bottom, and they are concentric, and say okay as well. So by doing this, the piece is actually there, so it can move with that. And now let's look at the next step. So the next one, we're going to put this fastener on there. So let's go back to SolidWorks and flip it over first. Then insert components and select oval filter. So this fastener instead of the other two. So select this one and open it and drop it down here. And now we are going to add relations. So we are going to make this surface and the bottom surface to be coincident. So let's go ahead and do that. Add a mate. So I want to select the bottom surface and also this surface, and say they are coincident, which they are already. And the next thing, I'm going to make a concentric. So make those two holes to be concentric, and select the cylinder and this cylinder as well. They're concentric already, and say okay. And by doing this, I put the fasteners in there as well. And as you may notice, the fastener is underdefined as well because I can move it, I can rotate the fastener in this way. And now let's save the work and rebuild. And now the clamping plate at the bottom is fully defined as well as we rebuild. So it's fully defined as well. And let's move to the next. Go to the slide. And now we are going to add the 4 fasteners at the bottom. So they are side screw 1 instead of 2. So let's do this first. Let's go to SolidWorks and flip it to the bottom. And insert the component. And select the side screw 1 and say OK with that. And now we have 1 fastener here. And we're going to mate that. So before we do that, I think we missed a step, which is put those 2 pieces there. Okay, those 2 bottom pieces there. So let's go ahead and do that first. So go to insert component and grab the base plate. So the base plate here, and say open. And let's drop this piece down first. And let's mate it together. So let's see if it has directions. Yes, it has. So this one is supposed to be made on this surface because the other surface, it has countersink bore. Okay, countersink bores here. So let's be careful of the direction. Let's go to mate and select this 2 surface. And it's the wrong direction again, so let's flip the direction. So by clicking this, and direction is flipped, now it looks right. And say OK with this mate. And now we are going to make the holes to be concentric. So select the hole as well as this hole and say concentric and say OK with that. And select another hole as well as this hole. They are concentric and say OK. And now let's check, see if it's fully defined. So before we do that, let's save the work. And let's insert another one. So I go to insert component and bring the base plate in one more time and drop it here and do a mate and click this surface and this and see the coincident with which already is, but the direction is not right. So let's flip the direction by clicking this anti-aligned. So the direction is flipped and say OK. And now we are going to make the holes to be concentric. So I am going to select this hole as well as this hole, and they're automatically recognize the concentric. Say OK, and select this hole as well as the other one. Now I can't see it, so I'm going to select this because they're the same and say OK with that. Ooh, doesn't let me do. Okay, so let me cancel this mate first and move this part so I can see it. And let's go back to mate one more time and click this circle as well as this, and it's concentric and say OK. And now let's say OK to the mate and save the work. And as you can see, both of the base plate, they are fully defined. And now we are going to put the fastener that we just brought in. So we are going to put this fastener inside of the hole. So first of all, we can make it concentric. And also we could make this face that mate this face. But for some reason it's not going to work. I think because the geometry of the fastener is not as the same as this hole, so they're not 90 degrees, I think. So what we're going to do is we're going to make this surface that is made to the bottom surface there, see if it will work. So let's do that first. So we do mate and select this surface as well as the bottom surface there, and check the direction, looks right to me, and this coincident, and say OK. And by doing that, the fastener should still be able to move left and right. Oh no, it's not, because the shape of the part, it has a groove in there, so it got be in there. So we don't need to put the concentrics anymore, because that's not a flat surface. It has a groove, so this is the only way that it can fit in. So that's all. But the part should be still underdefined, because as you can see, I can move it. And in reality, we do not need to fix this. So we'll just leave it in this way and say OK with it. And now we could bring the other 3 fasteners in there and add relations or mates individually. But we have a shortcut, which is we do a pattern. Okay, linear pattern. So I am going to select this fastener and do a linear patterns here. So I don't need to bring each fasteners individually and add all mates individually. So I am going to go to linear component pattern and select the linear component pattern. And now I'm going to select the fastener. So as you can see, if I do in this way, it's only selected the surface, which not what I want. So I am going to go to the tree here and select the fastener. So I guess it's this one. So as you can see, it's highlighted. So this is the right one. So I click this. Oh, I'm in the wrong place. So this is the direction actually. So I am supposed to go to the components and select the fastener, which is this one. That's selected. Now I am going to give a direction and click the first one. So I want to going to along this direction. So I am going to select a line. So either line, this or this. So I am going to select this line. In the direction the arrow point out to this way, which looks right to me. And the number of that, I want to have 2 of them, 1, 2. So I'm going to change the number to 2 and go to the second direction. Oh, before we do that, let's give a distance. So let's figure out the distance between these 2. So let's go back here, go back to the drawing and look at the dimension. So the dimension in between is 70, and let's figure out the other dimension as well. So the other dimension here to here is 44, so 70 and 44. So let's go back here and give a dimension 70. And this is the preview, looks right to me. And let's give a direction 2. So I am going to do a pattern in this direction. And let's find a vertical line. So this is a good one. So this is a vertical line. I select that. And by selecting that, the arrow pointing out to this way, which looks right to me. If it's not, then you could flip the direction by clicking this. So as you can see, the arrow is pointing out to another way. So this is a right. And the distance was 44. Okay. And we want to have 2 of them. And see 2 here, and let's look at the preview. So 1, 2, 3, 4, we have all of them in the right position, and we say OK for the linear pattern. And now we have 4 fasteners there since it's a pattern. So if I rotate one, all of them is going to be rotated together, and they are all underdefined because we have not because they can rotate, we have not given a dimension, the relation between here to somewhere, which we don't need to. And let's see what we are going to do next. So the next one, we are going to add those two screws as a set screw tool. So let's go back to SolidWorks and insert component and select the screw tool here and say open and drop the screw down here and let's do a mate. So select this surface and also with this surface and let's check the direction. Yep, looks right to me, and say okay with that, and that should be all we need. Oh, it's not, it can still move out. Oh, I guess I selected concentric instead of the mate. So let's go ahead and fix that. So screw tool here and the mate in bench vise. So this is concentric. So we right click and edit that. So instead of the concentric, I want them to be coincident. So I'm able to make the selected entities, maybe because the surfaces, they're different, they're not exactly the same. So let's go ahead and say no for that, and let's delete this relation, this mate, and redo it, see if we can. If we still can, we're going to mate the bottom piece like we did for this fastener. So let's go to mate and select this surface and this surface and see coincident, still can't. Okay, then we're going to do something else. We're going to select the bottom here, so the surface as well as the inside surface. Can't see it very well. So the inside surface, which is this, and say they coincident. Okay, coincident, and say okay with that. And now they are installed there. So the reason it can't be mated because the shape is different. So as you can see this, they are not exactly mated. Anyway, so we'll make the bottom part to be mated. And the same thing, we're going to do another screw. So we insert the component one more time. It's a set screw tool and say open and drop it here and do the mate. So the surface here as well as the inside one, make sure select the surface only instead of the hole, and the direction looks right, and say okay. And now the screws, they are there. And let's go to the next. So next one, we're going to install this part as well as two little balls at the end. So let's go to SolidWorks and say okay for the mate and insert the component and select the screw bar and open it and drop it down here. And now we are going to make this bar as well as a hole to be concentric. Before we do that, let's save the work first and rebuild the part. And let's go to mate and select the cylinder and as well as this hole and make them to be concentric and say okay. And now it can insert in there. Now let's bring the two little things. So say okay with the mate and insert component and bring the bar globes. So say open and put it here. And when you install or assemble this part, make sure it has a direction. So the part that we had chamfer there, they're supposed to be insert in. So that's the reason we put a chamfer, because it's easy to install. So we are going to install the one with the chamfer in. So let's add a mate, and we are going to put this surfaces to be coincident. Let's see if we can do that first, because the shape they're different a little bit. So let's select this tool, see if we can do that first, and see they're coincident. Yeah, we can do that. That is great. Then say OK with that. By doing that, this part can still move in this way. And now we are going to add a concentric relation. So we select this cylinder as well as the other one, say they're concentric, and say OK. Now the part can move. And actually it can still rotate in that way. So this part, it can still rotate, and actually in reality it's supposed to. So we just leave it in there. And let's put this part one more time on the other side. So bar globes, and say open, and drop it here, and make sure you assemble in this part in. That's the reason we put a chamfer there. So go to mate and select the surface as well as the surface in there, and coincident, which is right, and say OK. And now we are going to add a concentric, which is this bar and this bar, and they are concentric, and say OK. And we have this part. Now let's give a good view and see what's going to happen. And put it here, and make it a little bit lower so I can rotate it. So first of all, say OK for this mate. Oh, I didn't select that, just exit that. And let's move. OK. And this is what's happening. So it can actually going out and coming in. And this is not in reality what is supposed to be happening. So now we are going to give another constraint which make it only work in there without coming out. Okay, so let's do another. Let's give access of that and create a plane so it does not go out, and give a distance so it does not move out. So I am going to create some axes. So I'm going to select reference geometry and do axis. Well, first of all, I want to get the axis of the cylinder. So I click that and create this axis and say OK with that. And by doing that, I create an axis 1. And I also want to create the axis of the cylinder. So I do reference geometry and select the axis, and select this geometry as well. And the axis is already there, which is good. And I say OK with that. And now I am going to create a plane that goes through the axis 1 and also perpendicular to axis 2. So I am going to do a plane that is, so first reference, I'm going to select axis 1. So go to axis 1 and make it went through, which is already did. And the second one, I select axis 2 and make it to be perpendicular. So this is the plane that I'm trying to create. So which goes through the axis 1 and parallel to axis tool and say OK with that. And now I am going to give a distance from this edge, so tells that it can only move from here, and from 0 there, and the farthest one is going to be the length of the entire part, but subtract the radius of the circle. So let me give another mate with that. So go to a mate and select the first plane, which is right, and also select the edge of this little piece. So this tool, and give a distance. So the smallest distance should not be like this, should be the so first of all, I go to the advanced mates, okay, advanced mates, then click the distance, and the smallest one is going to be the radius of this part. So let's go back and find out the radius of that part. It's going to be the bar. So the distance is going to be 10 as the radius. So we go back here and tap the radius as 10. And the largest one is going to be, so the overall, which is the bar, so length, and subtract those two sides, and also subtract one of the radius. So let's go ahead and figure out that. So it's 104 minus 10 minus another 10, and minus this 10 there. Oh, I think I made a mistake. So that's not the radius. So the radius of the bar should be this. So radius is 9. Okay, radius is 9. I'm going to go ahead and fix that as well. So the maximum is going to be 104, subtract 10, subtract 10, and subtract 9. And the smallest one is going to be 9. So let's go ahead and put it back there. So it's 104, subtract 10, subtract 10, subtract another 9. And the smallest one is going to be 9. And say OK with that. I don't know if it's put it there. Say OK with that. And close the mate, see if it works. Yeah, actually it works, right? So only moved in between. Okay. And let's flip it to the front view, and we could move this part up and down, okay, and also move this part in and out. And let's save the work first and rebuild. So by doing this, you should have the vice body fully defined or fixed, and the vice jaw is fully defined, no minus sign, and the clamping plate, which is the bottom piece, should be fully defined as well. And also this base plates, this two, they should be no minus signs in front. And all the screws, you will have that because you can still rotate them, okay. And also this part you can rotate as well, but you can only put it up and down in certain dimensions, not all of them. And if you get the same thing with me, then you're all set for this part. And let's give a good view. And I want the asymmetric view. And give a good view once again, and save the work, and rebuild it and save it. Then you're all set for this assembly. And thanks for watching the video. We'll see you next time. Bye.